Hello, everyone, and welcome to this Stranger Danger. And this is going to be a live hacking session in which we both break into and secure our applications. And we're going to be doing this with, of course, your assistants as people who are going to be answering my questions and providing us with a number of different ways in which we can try and attack these applications. So together, we're going to be breaking applications and trying to find information as attackers onto these applications. This, just to give you a little bit of background about this webinar, obviously this webinar is probably going to be about 50 or so, 45, 50 minutes long. It is a recorded webinar, and we will be sending you links out in an email after this to everyone who is registered. If you have any questions around the topics, either generally or specifically about what I'm talking about, feel free to write in the chat, or there is a Q&A. And I think, in fact, from previous sessions, if you ping directly in the Q&A, that's the best area in which I can see them in. So as I ask questions, feel free to answer them in the Q&A there. Okay, I don't think there's anything else to cover there. So why don't I briefly introduce myself as to who's talking to you right now. So my name's Simon Maple. I run the developer relations here at Snyk. I've been here 3 years this week, actually. So coming up to my 3-year anniversary at Snyk. We're a five and a half year old company, and we're a very, very developer first company. We love providing developers with awesome tools that they themselves love, and that's what we do. We scale security through developers. So my background is as an engineer. I've been a Java engineer since I left university 20 years ago, and I've worked through IBM, a couple of other companies, and found myself here at Snyk, where I'm doing more developer advocacy, so speaking on webinars and conferences and to customers and prospects and a whole bunch of other things. My passion is all around community, and I've created a few communities, and I'm a big part of other communities. A couple mentioned here. The Virtual Java User Group was a community I founded 8 or 9 years ago, which is an entirely virtual Java group where people can consume content just like this, but more focused on the Java ecosystem. I run a physical user group called the London Jug, or the LJC, which is the London Java Community, and also a security one which I help out with. This is the Secure Developer podcast, but also DevSecCon, which is a conference and virtual community. Okay, so without further ado, I'm not going to go through too many slides, but there will be a couple, and this is just to kind of like set up some of the thought process that we need to really go through in terms of when we look at our applications and what we need to secure. So let's go back 5, 10, 15, 20 years, depending on how long it was since you adopted cloud native applications. Now, pre-cloud native, this is a very traditional stack where you have hardware, you have some kind of virtualization, you have some router config, you have virtual machines sitting on top of that, some IT applications, things that the actual app that we deploy as developers would interface with and interact with. So there is a large amount of the stack that is looked after by the IT team, the platform teams, and what a developer would need to do is it pretty much just write the code, custom code in their IDE of choice, and pull in open source libraries to support frameworks, or whatever it is to support that application. So the developer focus was pretty small. And of course, back when I started 20 years ago, it was very much, you had development teams, you had test teams, you had security teams, you had HA teams, you had performance teams, and so forth. And the developer role was actually a lot more simpler and a much more thinner kind of slice of what application development is today. Now, if we look at the application today, we can see a lot more of it has actually pushed into the developer scope. And if we think of what an application contains these days, including our container that we deploy in, the infrastructure as code, the IAC artifacts that will go alongside these container environments, a lot more of this is actually handled by the developer. A lot more of it is checked in as code. And as a result, a lot more of that gets maintained, needs to be secured by the developer. Now, with each of these areas, so cloud services, containers, mesh networks, Kubernetes config, IAC, like Terraform scripts, all of this provides their own security risks. And when we think about that, we need to understand from a developer's point of view what tools we have available to us. Now, we are very, very familiar with our own custom code, the code that we write in our own IDE. It's, fair to say that most developers will run some kind of security testing on that, maybe SAST, or at least some kind of static analysis, whether it's QA fixing, bug fixing, that kind of thing. We sometimes actually focus too much on that because we don't see the application for what it really is. We actually see it as just the piece that we write in our IDE. But custom code is something that is very in focus to a developer because it's what their teams are really exposed to most often. However, there's a large amount of this iceberg which sits underneath the water, which actually constitutes the majority of the application that gets deployed. And we'll talk a bit about that in just a second. But the three areas that we're going to focus on here is, first of all, the open source code. These are the libraries, the frameworks that we pull in as part of that application. And it actually constitutes 80 to 90%, often a lot more, of your application. When we see where the vulnerabilities are, where the security risks that could impact us, we see that the vast majority, 4 in 5 here, are found in indirect or transitive dependencies. So these aren't even the dependencies that we explicitly write in our package JSON or POM XML files that we say we depend on. It's actually the dependencies in libraries that they themselves depend on, and they depend on, and so forth. So our custom code depends on third-party libraries, and in fact, it depends on this dependency graph, this tree of dependencies. And it's very, very important that this is one of the areas we even potentially start at when thinking about securing our application. When we think about software supply chains, what is a supply chain? Well, a supply chain is really, all the pieces that we need to pull in, the things that the things that we're supplied with to create this piece of software, this application, and get it running. In an open source library, where we get that from, who maintains that, this is all part of the software supply chain. The next part of that, these days we don't just have platforms that we just deploy things onto, like we did perhaps traditionally. Much more of our production environments are deployed as containers, smaller containers that kind of like run, many of which, scaling in different levels, many of which are very portable and we can drop on different cloud environments and so forth. But these containers, while they're very beneficial for our agility and our ability to deploy very fast, they do also bring with them hundreds of Linux packages. And this also, when we think about that open source code, the number of libraries and frameworks we pull in there, the containers do a very similar thing. There are many packages which themselves have dependencies on other packages, etc. And we create, again, this dependency graph of packages in these from these containers. And typically, that's very much a one-liner at the top of potentially a Docker file or something like that, which pulls in an image, which defines which packages need to be pulled in. So potential for hundreds of vulnerabilities in your containers as well. And then finally, when we think about the automated world that we want to live in, infrastructure as code is something which is very crucial for this to occur. And all of these things, from custom code all the way through to infrastructure as code, tend to be artifacts that are checked into a Git or some kind of code repository. One of the core things with infrastructure as code that is a big issue for people is misconfigurations. It's very easy to put together a Terraform script or a Docker config, but it's extremely easy to misconfigure that such that we deploy yet another Amazon S3 bucket which has a misconfiguration, allowing it to be, maybe even openly public to the rest of the world. So this is, and you can see the stat here from the NSA, the #1 cloud vulnerability is misconfiguration. Now, when we think about custom code and infrastructure as code, one of the ways in which we can look at these is to perform more of a static testing, a SAST style, whereby we look at the custom code, we look at the patterns, we look at the infrastructure as code, and we try and identify misconfigurations in the infrastructure as code and insecurities in the custom code. Whereas the open source code and containers, we're more looking at known vulnerabilities that exist in those libraries, frameworks, and packages, and identifying which ones should be upgraded to what versions, etc. So these are four of the areas that we're going to be looking at in just a second. Now, let's focus on your application code that we would deploy into a container first. Now, when we think about this, the code we write is actually very small in relation to the code that we deploy. And we can see here, you know, the small piece in the middle. This is what we deploy into our. This is what we write in our IDE, and we have connections from our code out into the wonderful world of open source, which pulls in a number of direct dependencies. They then pull in transitives, etc., until we get this dependency graph. So let me give you an example. So here's a serverless example. We have 19 lines of code. These 19 lines of code pull in two dependencies, and you can see that on the top left there where you have the requires. In the package JSON, we will have these two dependencies that we pull in, and these are two direct dependencies. So these are dependencies that we have stated we need to download, pull in, and then the build system will pull in any further transitives. Now, my question to you is, and feel free just to answer or put it into the Q&A here, or if the chat works for you as well, do that, but I'm not sure I'll see it. But in the Q&A, my question is, how many transitive dependencies do you think this node application will pull in? So in other words, what is the tree of dependencies that the AWS SDK and also the node fetch dependency, how many dependencies will they pull in? So feel free to answer that in the Q&A, and I will describe what I see just here. Okay, we have a couple of answers in. A couple of people saying 100, one saying 250, one saying 50, and this is very common in terms of almost overestimating the number of dependencies that we have. 500, someone says, 20 or so. Very good from, yeah, so I won't give full names, but Jonas, you're pretty much spot on there with 20. The actual answer is 19, and that includes indirect as well as direct. So what we have is the AWS SDK and the Node Fetch SDK pulling in a number of dependencies, those pulling in a number, etc., etc. And now we have 19 lines of code with 19 dependencies. So my next, and Mike actually saying potentially 1,000 plus. Yes, actually with NPM in particular, you can see the number of dependencies grow hugely with node applications, because it's very common for particularly in the NPM world for packages, libraries to be actually very, very small, 1 line, 2 line kind of libraries. So you will see in those cases almost like needless libraries being pulled in, because it's basically a one-liner in your code, but that's the way the world is. So my next question now is, with those 19 dependencies and the 19 lines of code we have, this constitutes the application which we want to deploy onto a platform, into a container, for example. How many lines of code do you think we will now be deploying into our production environment? So in other words, how many lines of code in our custom code, as well as in the code of our open source dependencies, do you think that's going to include? So again, feel free to drop into the questions. Let me pull that out. There we go. Okay, a couple of answers coming in already. 1,000, 5,000. Any more suggestions? It's quite interesting that the number of packages, people tend to always go overestimate number of lines of code in our application. People tend to underestimate. I'll give it just a couple more seconds. 10,000, 50,000. One answer just coming in. Okay, well, the actual number is, drum roll, 191,000, right? So now with this small 19 lines of code serverless function, we actually have to support almost 200,000. And I will caveat that with the statement that not all of those lines of code will be active And in fact, James just says, yeah, AWS is 58 meg, right? So probably quite a lot more. But yeah, almost 200,000 lines of code. Those are not always reachable, but there is a significant difference between the lines of code in our IDE and the lines of code in our application. So I promised you not many slides, and I will live up to that promise. So we're going to do some live hacking. Let me grab a terminal quickly. Let me get rid of GoToWebinar. Okay, I'm going to show you an application. We're going to do a couple of hacks first of all. Let's go into the application first. Whoa, look at that. Get rid of these. This was from a previous session, obviously. Didn't quite clean up after myself. There we go. Right. So this is an application called Goof, and it is an open source application. You're more than welcome to check it out on the Snyk GitHub workspace. Now, this Goof application is an application which has known vulnerabilities. So the vulnerabilities that it will have are largely in open source libraries. So we pull in real world open source libraries at vulnerable versions, and we're gonna attack a number of those vulnerabilities today. So I'll give you a very, very brief intro to the application, then we'll scan it and have a look at the what we can see. Right, so the Goof to do, I'm going to do something, a couple of things. Let's buy some milk. As you saw, I did that previously. Let's buy something different. Let's buy some beer, but in this case, because beer is so important, I'm going to put asterisks there, and we use Markdown to turn that into a bold word. So we can use Markdown in here as well as just regular text. So it's a to-do application. There is also an about, and you can see here just some text or HTML that is being served here from the public directory. So that's all I'm going to show you. I'm going to log into Snyk, and everything I show you here today is going to be free from Snyk. I have already logged in. I'm going to go into my integrations, and what we're going to do is we're going to scan this application. And I'll show you how we can scan at the various different pieces of the application covering that cloud native platform, so that we are looking at application security no longer just from a what am I coding and what am I pulling in as my third-party libraries, but how I'm deploying and what about my infrastructure as well. So I'm going to go into GitHub, which is where my project lives, and under my repo, there's this Goof Kubernetes application which I'm going to import. So I'm going to add that selected repository. And now what Snyk is going to be doing is it's going to, oh, actually, I'm not sure. Yeah, this should be okay as well. What Snyk is going to be doing now is it's going to try and find a number of vulnerabilities that could exist in this application, potentially in my code, potentially in my third-party libraries, as well as my container image, as well as my infrastructure as code. So if I click view log here, you'll see it's already found a number of things. So we've found a package JSON, a Goof Mongo deployment, a Kubernetes JSON, and a Goof deployment as well. In fact, what I'm going to do is I'm just going to quickly log out, and I'm going to log in. I was actually logged into an incorrect account. I'm going to log in via my GitHub account because this will actually give me a slightly different. I'm going to import that again. I'm going to get a slightly different version of that, which will also get me my own code as well. So let's grab Goof Kubernetes. There we go. Add that selected repository, and you'll see here this will get tested very, very quickly. In fact, that scanned straight away. And if I click on view log, you can see automatically it finds certain things like Snyk code supported files. Snyk code is what we use to it's our product to scan your custom code. So if I was to view that project straight away, you'll see a number of things. In this case, looking at things like cross-site scripting. So cross-site scripting, command injection, SQL injection, and each of these are issues with the code that we ourselves write. Let's go into one and take a look. Here, command injection is the ability for a malicious user to come in, provide us with some third-party input potentially, and for us to actually go ahead and execute that third-party input or locally on our machine. So here, this is all about unsanitized input, and this is a key thing which developers miss time and time again. And it's about when we get some kind of input from a user, and in this case, this is from an HTTP request body. It flows into an exec call without sanitization, and sanitization in this case could be to look for certain characters, etc., that will stop and block these kind of injection attacks. SQL injection, again, we call straight into the database from an HTTP request, grabbing the username directly from the HTTP request without doing any parsing, and we're effectively, if this has malicious content in this username, we're passing that directly to our database, and we could effectively give back more information than we require. So this is our code, and this is the code analysis of our application. What else have we seen? Well, we've seen quite a lot. We've done code. We've also got our package JSON. Let me go back out and show you that package JSON. In fact, what I'll do is I'll just open it. If I go to my projects, I'll just open it like this, and you'll see exactly what we've got. Code analysis, package JSON. So this is a Node application, and the package JSON is the file which constructs our dependency graph. And we can see 40 high sev, 34 medium, and 6 low. If I click on the package JSON, first thing I want to go to is our dependency graph. Now, I can show all dependencies or just those with vulnerabilities or license issues. And here we can see where vulnerabilities exist in our direct dependencies. In this case, the ADM zip at version 047 has a high sev vulnerability. We also have body parser here, which if I open up, has a transitive dependency called QS at version 224, and this has a high sev vulnerability. So what's the fix to actually eliminate these vulnerabilities? Well, as a developer, I don't necessarily care about the vulnerability too much. I care about eliminating it. And what I want to do is either pull this version up from 047 to the closest version I can, whereby the maintainer of this library has fixed this high sev vulnerability. Similarly with QS, I want to pull in body parser at a version closest to 190 that has the fix, consumes the fix for the QS vulnerability, this high sev vulnerability, which will put it in a version, the minimum it needs. And the minimum, we require the minimum because it has less impact on our application. If I was to jump this from body parser 190 to 1090 or 1000, there's a good chance that my code is now not going to work with that body parser because my APIs that I was using are now invalid. Similarly, even if it's direct, it doesn't really matter. You're gonna have potentially the same issue. So we want to keep them a small jump to reduce the impact on our application. So let's go to our issues and let's find an issue that we're going to attack. So the issue I'm going to attack first is a directory traversal. And this is the directory traversal that I'm going to attack. It's in the ST library. And for those of you who are Snyk users, you may have seen this is actually looking a little bit different to normal. And we've just made some UI changes. So this may be a little bit less familiar than you're used to, but it's all good. So this is a medium sev vulnerability in the ST library. It's a directory traversal. You can see more information about that vulnerability, including a CVE attached to it. In this case, there's no CVE attached to this one. So this one was found by Snyk rather than being pulled in from a vulnerable place. Sorry, being pulled in from a public vulnerability database. So what can we say about this? Well, there's an exploit available for this proof of concept. It's a published exploit. You can see it has a score here, which is a priority score. So as a developer, I might want to filter based on priority scores. As you can see here, I can change these depending on what my priorities that I care about are. This priority score depends what the CVSS score is, which is the score of the vulnerability itself, whether our fix is available, because that means I can action it. So you can prioritize it based on a number of different things. Now, a couple of key things here. Introduced through and fixed in. Introduced through means this is the version that we are using in our application. Fixed in is the most important thing, which is what do I need to do to change my application so that this vulnerability no longer exists here. From a modern development environment, we care that developers are spending the time they need to not just find vulnerabilities, but have the actionability, have the empowerment to go ahead and make those changes. So what we at Snyk do is we provide a number of different things. First of all, we provide you with what the remediation is. Secondly, I can click this fix this vulnerability button. Now, because we imported this from GitHub, I can send a pull request out to fix this directory traversal. So I keep selected that one vulnerability, and then I open a fix pull request through Snyk to my backend repository. And what that's going to do is it finds, again, as you saw, the minimum jump that is required from 024 to 025. And if I click files changed, you'll be able to see that exactly being changed in my repo there. So 024 to 025. Now, if I was to merge this, assuming there's no conflict with my APIs, with my API calls in between those versions, and this is a minor change, so I doubt it. If I was to merge that, the fix is there, and we wouldn't be able to hack that application. But I haven't merged it, and this application right here, which is running in a Docker container on my machine, is currently live and exploitable and vulnerable to this behavior. So what is allowed to, I'll give you a brief explanation as to what a directory traversal vulnerability is, and then I'll ask you the question, where should we try and hack this application? Give me some answers as to what you would do. What would you do to try and break this application with a directory traversal? And like I say, I'll tell you what that is. So a directory traversal is where an application gives you access to a specific directory. And what you want to do is you want to break out of that publicly accessible directory, and you want to break out of that and find yourself in a more private directory to try and ascertain or gather information which is potentially sensitive about that system or about individuals or about the application and so forth. So this is about how can we get data from the system, from a space on an application or on an environment that we should not have access to. So we want to traverse out of a known directory. So any thoughts? Feel free to drop that into the Q&A. Any thoughts? Let me check the chat as well. Any thoughts about how we might go ahead and break this application and try and traverse a directory on this system? Any thoughts? We've already had a couple of options in. One of which is to use the input box. This input box here. The other one is to use the choose file. So the input box is a good suggestion. If we think about the input box, are we actually integrating with the directory system here, or is this potentially something which is ultimately being used to store maybe some data on a database or something like that? Choose file is a good one because it sounds like it's something to do with the file system, although that is a different vulnerability. So we're not going to be touching that today. Interesting question option from Sven. We might use the markdown integration to source something from ... Okay, so this is interesting. So we now the first suggestion of a ... So ... is correct in terms of it's a directory traversal, right? And in fact, James just also said that. Oh, excellent. Yep, James has got this one. So ... is correct. Okay, this is how we traverse. We want to kind of like go up to our parent directories and try and break out of a known public directory. James says, look at the about, but with ... So Sven and James were both along the right lines. So let's take a look at this public. Let's take a look at this directory. Now I'm going to curl this for two reasons. First of all, so I can show you three reasons. First of all, reason one, so I can show you this wonderful about pages looks just as beautiful from my terminal as it does in a browser. Secondly, because I know this hack will only work at a terminal as opposed to a browser. And thirdly, because hacking requires a terminal because it looks cooler. Maybe we can traverse instead of accessing the public directory, says Sven. So yes, that's exactly what it is. What we're going to do is, so we remove the about and we add the ... We're trying to traverse outside of the public directory. Public is something, in fact, what I could even do to start off with is just do this. Now, my question there is, who thinks that's a vulnerability straight away? The fact that we are being given more information than we need about a system could be considered leaking data, okay? maybe this isn't sensitive data, but it's still leaking data. I am being provided here. All I need to see at this stage, from what we recognize here, is the about HTML. Yet we're being given the directory listing. We're seeing other things that we potentially shouldn't see. So that could be considered a security issue from the point of view of the application. But the question, and I think James and Sven are on the right lines here with the // is this is trying to break out of this public directory, right? So let's run that and see. Whoops. Let's run that and see what we get. So we did the // and we've got some HTML back. We see buy milk, we see delete, we see goof to do. So we're actually, this is the homepage. This is the homepage of our application, and it's the homepage because the library which we're using to do the directory traversal is a public, it's a genuine library called ST that does static serving of, serves static files, and it knows what directory traversal is, and it is very aware that someone who tries to perform a // is likely trying to do a directory traversal, so it blocks it and it sends you to a safe page, which in this case is our home page. So the ST library recognizes what we're trying to do here. It recognizes the // and it stops us, it blocks us. So we're really close. How can we circumvent the sanitization of the ST library and still try and break in? So we still want to do exactly what we're doing. Is there another way of sending the same request, but by not putting the // Any thoughts about that? Think about it from the point of view of what a library might need to do to try and spot illegal characters in this URL. Is it trying to find a .. and try to recognize, oh yes, that's a directory traversal, I'll ignore that. But is there different representations we can do? Okay, James says ASCII escape the dot. So if we was to do an escape, I guess something along these lines is what you're suggesting, James. Okay, that didn't work. It's not so much the escape, because these dots, they're still being recognized as dots. We're not necessarily escaping. Oh, there we go. Mike got it first, then Jonas as well. URL encoding, the .. characters. Any idea what the URL encoding of the dots are, either Mike or Jonas or anyone else? And a URL encoding, let me show you what a URL encode is. %20, for example, is the URL encoding of a space. So you may often see that as you copy paste URLs and things like that. %20 is the URL encoding of a space. Well, I'll give it to you here. The dot encoding is a %2e. So if I was to do %2e, we're still representing a dot. There we go. And I like E2. E2 is very close, James. %2e is the URL encoding of a dot. So if we was to send that now, we are circumventing the fact that it is looking for a dot because the ST library doesn't transform that %2e back to a dot. And voila, our first hack of the day. There we are. This is the directory listing of the directory, the parent directory, as we can see, because we are showing public as a directory. Now, why couldn't I have done this at a browser? Well, if I was to do this at a browser, in fact, let me just go back here and do this at my browser, %2e, %2e. If I was to run that, we go straight back to the home page. And what this homepage ultimately is sorry, why we're getting to this homepage is ultimately because this %2e that we can see here, just to make it a touch bigger for you, this %2e is being normalized by the browser, so it actually gets decoded by the browser before being sent over to the endpoint. So my browser is what is messing this up for me if I wanted to oops, this is just the public, but if I was to do that with the browser. Whereas with curl, whatever I send, this is raw, I'm sending it directly to, curl is doing nothing to that for me. So you kids call it URL encoding. Yes, old school is ASCII escape. Sorry, James. You'll get the credit for that one as well. Awesome. So what would you do now as an attacker? Okay, you're an attacker. What are you going to do here? Are you going to try and find some information about the app, about the environment? What would you do to learn more about this system? Because when we think about it, Attackers don't just kind of like break in, grab some data and run. If you look at a classic, if there is a classic exploit, something along the lines of the Equifax break, attackers were in that system for like months, a couple of months before performing the actual breach. So during that time, they were learning about the system. They were trying to find better ways in. What would you look at here, just from maybe the directory listing or just your knowledge about environments and systems? What are the kind of things that you would want to look at? You tell me what you want to see, and I'll show you directly here. Okay, one person wants to have a look at the source code. So, oops. One person wants to take a look at the source code, so we can do that quite comfortably. So app.js, if I wanted to do that, we can see the source code. So we can see that we're sanitizing the marked library in here. Oh, there's a secret token. Jonas wants to take a look at the Docker file. Let's take a look at the Docker file. And Sven, also the package, Json and Docker file. Wow, everyone wants to see the Docker file. Awesome. Let's have a look at the Docker file, shall we? Okay, this is the Docker file. We can see exactly what image we're using, what parent image we're using. I might be able to see a number of other issues in here. I noticed we're not actually using user. What we should see is something like user, maybe node if we're using Alpine, and maybe a node if we're using Alpine and the node image, because that provides us with this very low permission user by default. If we don't use the node directive, any ideas what, or the user directive, any idea what user we're going to be using? That's right, root. A couple of people said root there. We're going to be using root. So as a result, we could potentially be in the root in the root environment here. Okay, a couple of other people want to see package JSON. Yeah, let's have a look at the package JSON. Okay, there's our package JSON. So as the package JSON, yeah, we can see direct dependencies. We can see what versions they're running. And as attackers, they're going to recognize, they're going to know which exploits they're comfortable with and familiar with. So, body parser, we could see from that the dependency graph that there's a QS is a transitive dependency that has a high serve vulnerability. We know that. We know Express has vulnerabilities. Dust.js has an interesting code injection vulnerability. Humanized MS, I know there's a regular expression denial of service. Marked has a really interesting cross-site scripting. ST we know has a few. TAP has a few as well. npm conf has a directory traverse as well. As an attacker, you'll recognize, oh yes, at this version. So like, I would say MS, I think MS at this version isn't exploitable to the regular expression denial of service, but humanized MS pulls in MS at a vulnerable version. So all, straight away we can find how we can start exploiting and what exploits exist. Also, find OS packages source. Yeah, one of the other things that we could do, if we are root, which it looks like we are, why don't I go all the way back to my root directory, and let's do something into my etc password, and there's my etc password of my Docker file. I can start looking at potentially, I mean, the etc password file isn't as useful now as maybe a shadow with something that contains hash passwords or something. This is the cliche though one, and the one I'll happily share with you. We can start looking at config of your environment, what's installed, what's around, those kind of things. Okay. All right, that's been fun. That was good fun. Next, let's jump out to our browser again. And I want to take you back to the Snyk Kubernetes, not the package JSON, my projects page. Now, in my projects page, we've seen two things now. We've seen the source code and how you can find vulnerabilities and fix vulnerabilities in your code analysis. And we saw some SQL injections, some code injection vulnerabilities. We saw on our package JSON, we saw some issues that could exist with transitive dependencies and vulnerabilities, known vulnerabilities that affected our applications. Now, this file is obviously packaged in a Docker file. I think actually this is slightly different to the one I've got deployed on my environment, but that's fine. If I click here, you can see, yes, we're using node image, base image 8. I think we were using a subtly different one here. If I was to go back to the Docker file, yeah, we're using a slightly newer one here, but that's fine. Also notice this one's a slim, okay, whereas this one is just a large base image, and you'll see why that matters in just a sec. But one of the important things is about the actionability. From a developer point of view, I don't care that this vulnerability exists in my application necessarily. I care about how can I fix it. The knowledge about it being there doesn't actually change anything other than I should fix it. As a developer, I want something actionable. I want to understand how I can eliminate it. And that is how we see the adoption growing through environments, through companies and organizations. How can we empower developers to fix it? So the way you empower them is to give them advice and to make it easy for people to fix. So here we have the current image is base image is Node version 8. There are 828 vulnerabilities, mostly low, but that's a significant number of high sev vulnerabilities. Now, this is a large image. There are also some upgrades that we can do if we decided to jump to a Node version. In fact, 12, that's similar to the version we were at just now. Still 561, but we've reduced our, looks like about a 70%-ish reduction in the number of high sev vulnerabilities. Now, what if we jump to a Slim? Now, a Slim effectively reduces the dependency graph that we have. It reduces the number of packages we pull in. And very often, the applications which we would go ahead and deploy on don't need effectively a full operating system to run on. They might just work just as well on a Slim because they don't use those packages. So maybe we can at least start on a Slim and see what else we can kind of like need to install to actually get our application working. Because what this does is it reduces the number of vulnerabilities significantly down to 10 high sev vulnerabilities, only 58 overall. And there could be some alternatives there as well, maybe a Buster or something else there. That could be very, very useful. Very similarly, dependency graphs exist in the same way you would expect. So you know, lots and lots of vulnerabilities across lots and lots of packages. Again, some direct, some transitives, and each issue will have exploits available. Some will be in the operating system packages, some will be in Node, etc. But these have fixes in certain versions, and we just need to recognize where we need to upgrade, where we can entirely remove different packages if we're not using them, etc. So this is, again, very similar in that SCA style. Okay, let me quickly show you an exploit, and we'll go ahead with that. Now, the application, the exploit I'm going to jump to here is going to be one in a new application. Here it is, this application, and this is an application which converts a photo into an ideal Twitter profile photo. So let me grab a new tab. I'm going to grab this dog. There we go. Okay, I don't need that anymore. I'm going to go ahead and choose the file here. We're going to go to recents, and I'm going to grab this new file. There it is, that one there. That's my little dog. I'm going to click on that, and I click resize, and there we go. A very, very smaller resolution photo, which is this same image. Now, one of the things about ImageMagick is it has an exploit that provides the ability to perform code injection. And this has a wonderful name of Image Tragic, this vulnerability. So Image Tragic is the exploit we're going to attack. Now, this application is running in a container that is running on my machine. And I'm going to take you right now to the exploits directory and pick rce1.jpg. This is the file which we're going to use, which will perform some code injection. And let's take a look at what that file actually looks like. So if I was to, in here, yes, I have the rce1.jpg. Now in here, as part of this graphic, we see we're filling this view box that we create, a 640 by 480 view box, with some data from this URL. However, as part of this URL, we are going to be breaking out. You can see we're breaking out of the file, and we're performing an OR whereby we touch rce.1, so a file called rce.1. Okay, this should be something which obviously shouldn't be done, but this is something which gets past the sanitization. This breaking out gets past the sanitization of this ImageMagick library. Okay, one last thing that I will show you is if I come here, this is now me SSH'd into that Docker container. So if I do an ls -1, you'll see, or an ls -la, you'll see that in this environment, there is currently no RCE file. So if I go ahead and click resize, I'm surprised it used that one. Let me go ahead, choose file, RCE1, resize. There we go. So no file there. That's the oops file, obviously, but something happened in the background. If I come back here and I do an ls -la on March the 3rd at 4:46, which was just now, we created an RCE1. So what we managed to do was we managed to execute the touch command on that remote Docker instance. Now let's try something a little bit more interesting. So that's kind of like our proof of concept to see if we can actually break in. Let's now try and do something a little bit more malicious. So if I was this time to choose a file, would you believe it, rce2.jpg. Okay, now I'm going to go ahead and show you what rce2.jpg is. If I was to come out here and cat rc, oh, actually not that one. Let's jump over to here. Let's from here cat rce2.jpg. What are we going to do? Well, we're going to again do some code injection. When we do an image over of we're going to do a little backtick here, and a backtick, as you may well know, these two backticks, this is everything between these two backticks are going to be evaluated. So when we do this evaluation, when we load this file, we're actually going to execute what's in between, and that is going to be wget, and that wget is going to pull the r.sh file from a known location at port 5000. It's going to pull that and it's going to echo that. It's going to put that into an r.sh file, which it's going to store locally. Then it's going to run that. And then for no reason at all, it's going to touch a file called A. So it's going to do those three things. Now, let me show you the r.sh file first. And this r.sh is going to do another wget. So this is the file that we're going to copy across. And I'm going to share these files from my laptop first. And then that way it will be accessible. What we're going to do is we're going to do another wget. And this time it's going to grab from the same location. It's going to grab netcat. It's going to extract it, configure it, make it, and then run and try and connect netcat to a listener port on, again, this local machine 3131. All right, so first thing I need to do is I need to serve that file. So where am I? Let's go in here. This is the folder I need to serve both r.sh and netcat. So I'm going to serve this here, serve dot. There we go, localhost 5000. Now when my Docker container tries to run this and start executing these wgets, it's going to grab these files from my machine. Right, second thing I need to do is set up a listener. Let me see if I've got a listener. Here we go. So I'm running netcat here on port 3131 as a listener. So if I just run that, this is now waiting for connections. And the connection is going to come when, of course, if I was to run, oh, sorry, I need to go back here. When I was to run this, the connection is going to come once that extraction actually occurs. So let's go through it. We're going to click resize. That's going to run some remote code on this Docker container. It's going to pull over r.sh. It's going to pull over netcat. It's going to kick off a netcat connection to my local machine, which is going to create a connecting to the listener. And then at that point, once it's connected to that listener, I've got a direct connection into that remote machine. So if I hit resize, this is just spinning. Something good is happening. If I was to come back here, I might be able to see if I come back to perhaps this one and type ls, I can see a number of things, lots of magic stuff happening. So this looks good from a hacker's point of view anyway. I've got netcat here, I've got r.sh here, no A just yet, but then we haven't finished the netcat session yet. Now, if I was to go back over to this environment, at this point, I've basically got a reverse proxy into that Docker container. So if I type ls, there is the ls of my Docker container. If I type, who am I? Wonderful, I'm root. If I type ps minus ef, oops, ps minus ef, there we go. Those are the processes running on that machine. I have now got a direct connection in to that container, and I have root privileges. So this is a great way of showing how dangerous something like that kind of a code injection could be, to be able to provide us with the remote code execution availability. Okay, so let me jump back over here and hop out one. There we go. So what I've shown you now so far is code analysis. I've shown you, so that's our own custom code. I've also shown you package.json, how we look at your application libraries and dependencies and how we can fix them. I've also shown you the Docker file and how we can provide suggested changes to that. And that's not a just looking at Sven's question here about no Alpine version listed. That's not an exhaustive list. These are just some of the similar lists, similar images that we could suggest so that your application would run on. So it's not exhaustive, but they're similar ones that that you could use. And then finally, we got some YAML files. So if I was to jump into one of these YAML files potentially, we'll see misconfigurations, and this will could exist in your Kubernetes config or your Terraform scripts, etc. What we're effectively doing is looking through your config here and trying to find misconfigurations in there, such as, let's take a look. Why don't we take a look at, this looks interesting. Container is running with a writable file system. Okay, so I can click on this and I can see exactly what's happening through here. I can see that the real issue is the read-only root file system attribute is not set to true. This doesn't actually exist here in this file, but that doesn't mean it shouldn't be configured. Okay, so the vulnerability doesn't just exist on lines of code that we have here, but also the lines of code that are missing. And these are often lines of code that developers don't recognize. If it was completely explicit and the option was there, a developer might go, yes, oh yes, actually, yes, it should be read only. But if it's not there, it's not always as obvious. So what is the impact? Well, the impact is a compromised process could abuse writable root file system to elevate privilege. Right. So, if someone does break in and they have write access, then they can actually start making changes. And you can resolve this by setting the security context.read-only root file system to true. So we provide you with what the issue is, what the impact could be, and then how you resolve that. So as a developer, I can see this straight away and I can make my fixes straight away. So it's very, very important as a developer that I'm not just notified, but I'm also advised as to what the remediation might be. So going back to what we were talking about previously with the iceberg, when we move over to a cloud native environment, there are many, many more risks that developers need to consider, because developers touch code libraries as well as containers and infrastructure as code. And it's very, very important that we as developers have the tool sets and the understanding and the education and the ability to know what to do when to fix them. A couple of ways in which we can do that. And in fact, I'll show you a neat little tool for those of you out there who are VS Code users, and we of course support a number of different integrations, but this is a cool little tool. If I was to VS Code, obviously massively used IDE, and as a developer, I'm going to want to import a ton of different libraries and then write my code. And as a developer, I want to know about where issues exist as I'm writing them. So here you can see the vulncost plugin is identifying where I'm importing and telling me how many vulnerabilities exist. So here you can see the ST library has 4 vulnerabilities. I can hover over that, click this little balloon, click fix vulnerabilities, and this will tell me where my vulnerabilities exist. Could be in my directs, could be my indirects, but then gives me a remediation. So this is the first stage where a developer wants to make sure that they're being they're testing and they're looking at their application in a good way. The second place, and in fact, I wonder if I can maybe go. No, I can't. Okay, no worries. Let me go into my package JSON. Let me fix another vulnerability. So let's just click on here and click fix this vulnerability. One of the key things that we also want to do is mandate that when changes are made and when things actually go to a central repository, we perform and police tests there. So when I'm a developer in my IDE, I'm not going to have someone behind me saying you need to fix this or you need to test this. So, you know, it could be that people won't actually get the enforcement there. However, when I create a pull request, one of the things that Snyk does when we attach ourselves to a repository, and that happens when we import the project at the very start, what this is going to do is it's going to run tests against that environment, against that change, and you can see how fast it is in terms of the tests have already passed. But what Snyk has done is in the delta of this pull request, so the changes that are made in this pull request, Snyk has tested those to see if new vulnerabilities or new license issues that run against our policy have been introduced. If they have been introduced, we can block that merge pull request. So as a pipeline, we can test here and police that we're not getting worse, we're not regressing, we're stopping the bleeding, as it were, before we try and fix the backlog. So as a developer, we can choose IDEs, we can choose our build environments, we can choose our CLI as to where we want to test. When we get to more teams, we look at the integrations with our CI/CD, our integrations with our source code repositories, and then when we publish this to our environments, production environments, we care about what happens when a new vulnerability becomes known. And at that stage, we automatically get a pull request from Snyk into that repository, which says a new vulnerability has been found. And as a result, you should perform this fix. So it actually sends a pull request with the change required to fix that vulnerability. So throughout the pipeline, you're continually testing, and even beyond a production push, you're continually monitoring your application. And this is how we can push security into a pipeline, get that developer adoption, get that maintenance and monitoring with very little effort from development teams and organizations, and they actually want to use security tooling because it provides them with the information they need to in order to fix. We have a couple of minutes left. Happy to take any questions. Mushin asks if the session is being recorded. Yep, it absolutely is being recorded, and I presume you're on this call because you got an email with the links, etc., to the GoToMeeting. We'll send an email to that same email address, and you will have that recording. Awesome, perfect. Then you'll have that in your email, and you can watch that at your leisure. No problem at all. Any other questions? Looks like, oh, question just in about whether you can use Snyk on-prem as well as SaaS. Yeah, so as well as SaaS. So everything I've shown you here with these dashboards are full SaaS. You can also use full on-prem as well if you like. Literally unplug the Ethernet cables and everything will work just fine. You just need to continue to keep your vulnerability database up to date. There's also a brokered version whereby there's a container that sits in the middle, and you can see what information and what content is being passed, as that is an open source container, open source application running in that container, and you can see what artifacts are being sent through from a security point of view as well. Okay, awesome. Thank you very much, everyone, for helping me out with attacking these applications. Thank you very much for your questions. And you can use everything that I've shown you today just by going to snyk.io and logging into your free account. Everything I've shown you is freely available today. And yeah, looking forward to seeing you next time. Thanks, everyone, and have a great rest of the day.